4.2, we're doing linear patterns. And that means that if it's linear, it's making a line. If it is making a line, that also means that it is either increasing or decreases. I don't know how to spell. Try that one more time. Steadily. So today we're going to represent these linear patterns with a table, words. You're going to have to write some words for me today. I know it's terrible. An equation and a graph. So what I want to kind of show you how it's all going to go together is I'm going to start with a table. All right, and then I'm going to show you how it all works before we start getting into examples. So, if I have a table, here's my table, and I have X and Y, and in this table I have 0, 1, 2, 3, oh, we'll go 4 even. And on this side, let's say I have 5, 8, 11, 14, and 17. Yeah. So, the very first thing we have to do is find out, see if linear. And if it's linear, we got to see if they're increasing by the same thing every time. That's step number one. The way I do that is with what I call loops. Okay, I start with the second one and subtract the first one. So 8 minus 5, I'm going to write this right here, equals 3. But I got to check and make sure it works for all of them. So I go 11 minus 8 equals 3. 14 minus 11 equals 3. And I have 17 minus 14 equals 3. If they're all the same, it's linear, which in this case it is. To write our equation, we follow in the form y equals, we're going to put a blank here, x plus blank. Step 2, the constant increase or decrease goes in blank 1. So in this case, the number 3 that we have a constant increase goes in my first blank. Seems pretty easy, right? Step number 3, number across from 0 goes in blank 2. So the number across from 0 up here is 5. So that goes in blank number 2 over here. No. You might have to take them back to 0, and we're going to get to an example of that, okay? It's not hard. All right, so any question how those fit into that equation? It's a pretty basic equation, right? So then if you had to put this in words and you're looking at this, this says it's increasing by 3 every time and starts at 5, right? Just rewrite that in words. Let's do one where it's not across from a 0, okay? So we have x, we have y. Let's go 1, 2, 3, 4. And let's go 2, 7, 12, 17. All right, the first thing we have to do is check and make sure that it's linear, right? So we go 7 minus 2 is 5. 12 minus 7 is 5. 17 minus 12 is 5. So when I write my equation, it's y equals 5x. Then I've got to fill in my blank. I've got to decide what goes in this blank over here. Now, if I go back to 0 up here, that means I have to get this one back to 0. Correct. It'd have to equal 5, so how would I find that? 2 minus 5, you're right. So what would that be? So it would be negative 3, right? So if you look at this, this is 2 minus a negative 3, right, would give me 5. So negative 3 goes in the blank. Okay? All right. So now let's talk about some examples a little bit closer to what's actually in your homework, now that it follows this idea. Okay? So here is example number 1. Similar to number 6 where you're starting. Make a table, describe in words, an equation, and graph. So we're going to draw a little picture here. First picture I have is a square, 1 square. The next picture I have is 2 squares connected. Next picture I have is 3 squares connected. All right, so now the first thing we're going to do is make a table. Over here on my table, this is the figure. So like this is figure number 1, this is figure number 2, figure number 3. Okay? And over here we're going to talk about the perimeter. All right. So for figure number 1, how many sides do we have up there? 4. Absolutely. For figure number 2, let's start here. I have 1, 2, 3, 4, 5, 6 on the outside, right? So this is 6. For figure number 3, I have 1, 2, 3, 4, 5, 6, 7, and 8. All right. So we have a table here. From that table, we've got to describe it in words. So we've got to see, first of all, if it's linear. Is it increasing by the same every time? 6 minus 4 is 2. 8 minus 6 is? So how much is it increasing by every time? Very good. So let's put that in words. It increases. Or we can say the perimeter, sorry. Increases by 2 every time. All right, now let's write our equation. We have y equals, what goes in my first blank? 2. So I have 2x plus. Now I got to figure out what I'm going to put at the end. Which means I have to take this backward across from my imaginary 0. 2. I agree. So then what are we going to put in our second blank? 2. All right, now we got to graph it. So we're going to graph. Down here is the number, the figure number. Okay, over here is the perimeter. 4, 5, 6, 7, 8. All right. So first of all, I have 1, 4. So at 1, I go up to 4. At 2, I go up to 6. And at 3, I go up to 8. Is that making a straight line? Okay. Now here's the thing I want to point out. In this one, can I connect my dots?
Yes. No, wait, they're separate.
They're separate because you can't have half a side, can you?
No.
Right? When we're counting the perimeter, there's not half a side. So we can't connect our dots. All right? So you've got to think about that when you're graphing, whether you can connect them or not. All right. This is generally what we're doing for most of the questions today. Any questions so far? Okay. Let's go to example number 2 then. Example 2. This is leg numbers 8 through 12. And it says, for the table, describe in words, equation, and graph. And so they're going to give you a table this time. X, Y. Let's go 0, 1, 2, 3. Let's say -3, -7, -11, and -15. All right, so first of all, I made this one a little bit trickier. We got to find out if it's linear in order to figure out if it's increasing steadily, right, or decreasing. So we go -7 minus 3. -7 minus -3. What do we get? -4. Very good. -11 minus 7. Good. -4. And -15 minus 11? -11? Good. All right. So is this increasing or decreasing? It's going down 4 every time, right? So this is decreasing at a steady rate. So decreasing by 4 each time. Right? You agree? Okay. Our equation, y equals, what number goes in the first blank? -4x. What number goes in the end blank? -3. That is exactly across from 0, right? Okay, last thing we have to do is put those numbers in a graph. Yep. 0, -3. 1, 2, 3. Put a dot. 1, 7, or 1, -7. Now, do I need to go over how to graph it all? I'm making the assumption we all know, but if we need to talk about it, okay. And then we have 2, -11, so 2, -11, 8, 9, 10, 11, and 3, -15. There you go. Questions at all?
So that one just put the, at 1 you put the -7.
Yep.
At 0 you put the -3.
Yep. Okay, example number 3. 2 more examples and I'll be done, all right? Yes.
So on one part I can line and
You can. You can. Would you feel better if I did? There we go. There we go. Okay. Next one, example number 3. For example number 3, this is going to be similar to 14, 16. 14, 16, and 20. All right. You can make 1 gallon of Kool-Aid with 5 teaspoons of powder. Does that really matter? Well, let's go with blue. Blue raspberry. All right. Using a table, make an equation, describe in words, and graph the amount of powder used. All right, so first of all, we're going to put in a table. So in my table, I'm going to have you start with the Kool-Aid on this side and powder over here. So for 1 gallon, it took us 5 teaspoons, right? For 2 gallons of Kool-Aid, it would take us 10. For, I don't know where that came from. There we go. For 3 gallons, it would be, right, and so on. Okay, seems pretty easy. We're increasing by how many teaspoons every time? 5. All right. So let's see, next thing it has to do was an equation. So we have y equals 5x. What about, do I need to add anything to the end? It'd be plus 0. Now think about this. That last number is where you're starting at. If we don't have any Kool-Aid, are we going to have any Kool-Aid powder we're using to begin with? So that makes sense that it's plus 0, right? Okay. So we have an equation. We're going to say for each gallon, increase by 5 teaspoons. Now let's put it in a graph. So we have 1, 2, 3, 4, 5. We have 2 gallons, 10. 3 gallons. All right, so I want to talk about on this one, would we connect the dots? Can we make half a gallon? Absolutely. Can we use half a teaspoon? Absolutely. So we would connect these dots. Questions? No questions? Okay. The only other thing I want to point out, I want to make sure I describe one of the problems and what it's doing. Now, mind you, my drawings aren't beautiful. I try, but they're not. So, question number 16 gives you 2 gears that are working together. Gear A and I'm not going to draw the whole thing, but I just want to give you kind of the, what's happening here. So this is gear A, okay? Gear B this is gear B with a big handle on it, and we're turning gear B. That's fine. But I want you to see that in the picture, and it's going to be easier for you to see it in the picture. Let's see if I can make this a little bit bigger. Okay? What they're trying to get you to see is how many times it's taking you to turn gear B to get it to take A all the way around. Do you know what I mean? So imagine as you're turning this gear B from my handle there, this goes into that one goes into that one, as it goes around. So as you finish one full turn of B, it's not going to finish A all the way around. So then you got to do it again, right? So when you're looking at the 2 pictures, you got to decide, is it going to take 1 time of B to get once of A? Is it going to take 2? Is it going to be 1.5? So you're looking at the 2 of them. Yes, sir.
For that, it's just counting them like together, like which ones will go in which spot.
Okay, let me try and say it again. Because again, it doesn't help that my drawing's not beautiful. But as you turn B, B is going to move this one, right? So this gear goes like this and falls into here. This moves this gear like this, right? So I want to know how many times it takes B to go around to get A to go around once. That's what's going to go. That's what's going to go in your table, okay? So you have gear A, you have gear B. For A to go around once, B maybe does 4 times. That's not the correct answer, but maybe it does. Which means in order to get A to go around twice, you have to turn B 8 times. Exactly. Again, you have to look at the picture. All right, but I just want to make sure that you understand what the picture is trying to say to you, okay? We're good? All right, go ahead and open your books. You still have like more than 10 minutes, so we can get quite a bit done. I can answer some questions that way. All right? Book. 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 Come on. Do you want to say that one more time?
Hi, Clara.
Hi, Clarion.
All right. So everybody's talking to you. You better watch this.